Hello everyone, this is Venkat and welcome to Project Java. Today we are going to talk about yet another important topic of digital electronics. And under that, we'll be discussing encoders. What are the types of encoders, examples, and what are encoders in general? So basically, these are combinational circuits which converts signal from one type to another type. Now, they are used in the reduction of the number of lines in signal transmitting. Let's say that I want to transmit a signal, a decimal signal from here, from Kolkata to San Francisco in USA. So for that, I don't want to have those 10 input lines of the decimal number system. What I can do is I can simply encode the data, the decimal number into uh, just three binary output lines, which I can transmit there, and with the help of a decoder, I can decode, or the person who is receiving the data can decode the signal. So encoders are used to reduce the number of lines in signal transmitting. They reduce the possibility of errors in transmitting the information and increases performance by reducing the time taken to transmit signals. And that's very obvious and very important when it comes to signal transmitting. Now, what are the types of encoders? Look, there can be numerous combinations of encoders, okay? Now, any encoders will have M input lines and N output lines. Now this M and N depend upon the radix of the number system. Let's say, like, what is radix? If you ask, let's say we are talking about a decimal number system. A decimal number system has numbers from 0 to 9. So it means that the radix of decimal number system is 10. Similarly, for a binary number system, it's 0 and 1. So the radix is 2. Now let's talk about the heart of encoder, which is input and output lines. In order to find out how many output lines are required to implement a number system of radix n, we use the inequality 2 to the power n is greater than equals I. So this is how an encoder looks like. I'll obviously show this diagram on the board. These are the input lines, and they can be many m input lines, and these are the output lines, which can be n output lines as well. So this is a m cross n encoder. Obviously, m is greater than n because the number of input lines must be greater than n. So in order to find out how many output lines we will require for implementing a encoder, we use this inequality. So let's say that I have an octal number system. So for an octal number system, the radix of an octal number system is 8. The radix is 8. So it means that I'll have 8 input lines. But what about the output lines? So let's apply this inequality and let's check it. So 2 to the power n must be greater than equals 8, which is the number of input lines. So we obviously know that 2 cube is equals 8. So we just require 3 output lines to implement the octal number system and to encode the octal number system. This is about the input and output lines. We'll know more about this on the board work. And these are some examples which you can try out after you watch the entire video at home, and you can definitely comment down your answers below. Basically, these are diagrams, so you need not comment them down. You can just practice them and we'll post the solutions soon. So let's begin with encoders and let's understand how exactly should we draw a block diagram of encoders if it comes in our exams. This is pretty simple to draw, okay? You'll think what is new in this, but let's do it. For example, an 8 cross 3 encoder would look something like this. It has 8 input lines and 3 output lines, obviously. And here 1, 2, 3, 4, 5, 6, 7, and 8. So how should we calculate these input lines, you might ask? And not only the input lines but the output lines. Well, input lines are given according to the number system and the radix of that number system. For a decimal number system, the radix is 10. For a hexadecimal, it is 16. So whatever number system you are having in the input, the radix of that number system is going to be the number of input lines in the encoder. And here, the output lines, how exactly will you calculate for a decimal number system? Using the formula, obviously, you will apply this formula. 2 to the power n should be greater than equals I, which means that 2 to the power n should be greater than equals 10. But 2 to the power 3 is 8. So, do you think 8 is greater than or even equal to 10? No, it's not, obviously. So, what we can do is we can write 2 to the power 4 is always greater than 10, which means you will have 4 output lines to convert from decimal to binary from an encoder. And similarly for hexadecimal, again 2 to the power 4 should be greater than equals 16. So yeah, 2 to the power 4 is 16. So for decimal and hexadecimal, the number of output lines is same. Let's now implement a 8 cross 3 encoder using the logic gate circuit diagram. We will convert the octal number system and encode that to a binary number system. Let's see how. So let's implement. What is the step 1 for this? Well, step 1 is to find the number of output lines. 2 to the power 3 is greater than equals 8. Why 8? Because we have 8 input lines for an octal number system. So thereby the output lines should be 3. Secondly, we need to draw the truth table for representing the octal numbers to binary numbers. Now this is a process of encoding these numbers into their binary equivalents. So let's hurry up and draw the truth tables. We'll require F2, F1, F0 and let's say X, which is the octal number. So let's write it down. And let's number it here 0, 1, 2, 3, 4, 5, 6 and 7. Now what you really need to do is you need to check where these functions f0, f1 and f2 have 1 in their output lines. So for f0 you can see that 1 is in equivalent octal of 1, 3, 5 and 7. Similarly for f1 you need to find it's in 2, 3, 6 and 7. And for f2 it's in 4, 5, 6, 7. So what is the next step? We'll implement the logic gate circuit diagram using an OR gate for this particular encoder. So here is the circuit diagram. So in order to implement the circuit diagram, what you need to do is you just number 1, 2, 3, 4, 5, 6 and 7 and you draw horizontal lines like this. You're done drawing the horizontal lines. Now you need to, for implementing F0 first, you need to see 1, 3, 5 and 7. Now just see on this board whether you can understand where 1, 3, 5, 7 are. So if you can already see it, well, draw the lines. 1, 3, 5, 7. And now you just use the OR gate to join them. And here you get F0. Well, yeah, this is this simple. You just see where the function is going high, You see the equivalent numbers and you draw the lines and connect them into F0. Then similarly for F1 we have 2, 3, 6, 7. Let's join them. 2, 3, 6 and 7. Well, after joining them we have F1, right? Similarly for F2 we have 4, 5, 6, 7, because we get F2 high in only 4, 5, 6, 7, so we'll join them for F2. 4, 5, 6, 7. Merge them up and a single line F2. This is an 8 cross 3 encoder using logic 8 circuit diagrams. Well, similarly, in the same way, you'll do it for decimal to binary, hexadecimal to binary, and so on. Let's get back to the presentation because this is it for this particular video. We'll talk about the examples in some other video. So we are planning on to make a video on decoders as well. Stay tuned with Project Java and subscribe the channel so that you get all the updates of Project Java. And that's it for this video. Please subscribe the channel, love the video, and share it with all of your friends so that they can also top in the next upcoming exams. Thank you.